The world watched, waited, and then received the familiar news. Scrub. The highly anticipated 10th integrated test flight of Starship was called off just minutes before its scheduled liftoff, postponing the colossal vehicle's next leap for another day. For the global community of space enthusiasts glued to their screens, it was a moment of anticlimax. While delays are a common feature of rocket development, this pause in Starship's journey offers a unique moment to reflect on the incredible pace set elsewhere in the company. Even as Starship stood down on the pad, another incredible record had just been set by its workhorse predecessor, the Falcon 9. This feat not only shatters previous limits of the space industry, but also serves as a powerful demonstration of SpaceX's operational maturity, a glimpse into the very future that Starship is destined to lead. In a breathtaking display of mastery, SpaceX successfully completed 3 orbital missions from 3 different launch pads in a mere 51 hours. This historic trio of launches demonstrated the full spectrum of Falcon 9's capabilities, serving commercial, civil, and national security interests in a rapid-fire sequence. USSF 36 mission. The marathon began on August 21st at 11:50 p.m. Eastern Time, as a Falcon 9 lifted off from the historic Launch Complex 39A at Kennedy Space Center. The mission carried the clandestine X-37B spaceplane for the U.S. Space Force. This was the 6th flight for the first stage booster, which, after separating, executed a perfect landing burn to touch down safely at Landing Zone 2. The second launch took place on the opposite coast. On August 22nd at 10:04 a.m. p.m. Tune, another Falcon 9 launched from Space Launch Complex 4E at Vandenberg Space Force Base in California, carrying 24 Starlink satellites. This was the 17th flight for this particular booster, a testament to its incredible durability. After its job was done, it landed flawlessly on the "Of Course I Still Love You" drone ship stationed in the Pacific Ocean. To complete the trifecta, SpaceX returned to Florida. On August 24th at 2:45 a.m. Eastern Time, a Falcon 9 launched from Space Launch Complex 40, sending a Dragon spacecraft on the 33rd Commercial Resupply Services mission to the International Space Station. The booster, on its 7th flight, successfully landed on the A Shortfall of Gravitas drone ship in the Atlantic. This 51-hour marathon of launches is more than just a number. It's the culmination of a decade-long strategy centered on reusability. This capability provides a cascade of benefits that have fundamentally reshaped the space industry. First, it has led to a revolutionary cost reduction. The first stage booster accounts for roughly 60% of the total cost of a new rocket. By recovering and reusing these boosters, some more than 20 times, SpaceX has slashed the cost per launch to a fraction of its competitors. This has effectively democratized access to space, allowing smaller companies, universities, and nations with limited budgets to launch their own satellites, an opportunity that was previously unimaginable. Second, it enables a dramatically increased launch cadence. By eliminating the need to build a new rocket for every mission, preparation time is significantly reduced. This high tempo eradicates the launch bottlenecks that once defined the industry, where customers would wait years for a slot. Now, large-scale projects can be deployed rapidly, and critical satellites can be replaced on short notice. Third, this combination of low cost and high frequency has enabled entirely new business models. The most prominent example is Starlink, SpaceX's own satellite internet constellation. Building a mega constellation of tens of thousands of satellites would be economically and logistically impossible without a rapidly reusable rocket. Furthermore, SpaceX's transporter rideshare missions offer an affordable bus ride to orbit for dozens of small satellites at once, creating a vibrant market for space startups. This impressive achievement, however, is merely a shadow of what is to come. When asked about this operational tempo, CEO Elon Musk suggested it was nothing compared to the future, tweeting, "In about 6 or 7 years, there will be days where Starship launches more than 24 times in 24 hours. To comprehend this staggering claim, one must look at the foundation laid by Falcon 9. If Falcon 9, with its partially reusable architecture, can achieve a cadence of 3 launches in 51 hours, what becomes possible with Starship, a vehicle designed for full, rapid reusability? The cost optimization will be on an entirely different scale. Beyond the frequency, there's the matter of payload capacity. Starship is designed to carry 100 to 150 metric tons to orbit, a colossal leap from Falcon 9's capacity of less than 25 tons. The cost per kilogram to orbit is set to plummet by orders of magnitude, from thousands of dollars to potentially just tens of dollars. The leap from Falcon 9 to Starship is not merely one of scale, but of fundamental chemistry and design philosophy. Falcon 9's Merlin engines burn a refined kerosene called RP-1, a reliable but carbon-intensive fuel that leaves behind soot, complicating reuse. Starship's Raptor engines, in contrast, burn liquid methane and liquid oxygen. This combination, known as methalox, burns cleanly, leaving almost no residue. This is a critical design choice for rapid reusability, as it drastically reduces the time and effort needed for engine inspection and refurbishment between flights. Musk later clarified the ambitious target, noting 24 per day would be peak. Sustained is more like 10 per day. Even at this sustained rate, the implications are revolutionary. A fleet of Starships launching multiple times a day would function less like a rocket company and more like a global airline, creating a constant highway to and from Earth's orbit. This isn't just an incremental improvement, it's a paradigm shift. Beyond its interplanetary ambitions, this airline-like cadence unlocks another revolutionary application: high-speed, point-to-point travel on Earth.
Being able to move people around the planet, make it feel smaller and more accessible. You could go anywhere on the Earth, in less than 40 minutes, basically.
Like you could go from LA to Sydney in less than half an hour. You could go LA to Tokyo in less than half an hour. You could go from New York to Singapore in half an hour.
While regulatory and logistical hurdles for such a system are immense, the sheer speed and efficiency promised by Starship could redefine global logistics and passenger travel. The same rocket that builds a city on Mars could also deliver emergency supplies across the globe in under an hour, or allow for face-to-face business meetings on different continents within the same day. This dual-purpose capability is what truly separates Starship from any launch vehicle ever conceived. This capability is the key to unlocking humanity's future in space. It enables the efficient transport of massive amounts of cargo needed to build a permanent base on the Moon and a self-sustaining city on Mars. For interplanetary travel, this high cadence would create regular transport windows, making trips to Mars a routine occurrence rather than a once-in-a-generation endeavor. Ultimately, it is the tool that could truly make humanity a multi-planetary species. Today, Starship remains on the ground, a silent testament to the immense caution required when dealing with the most powerful rocket ever built. Scrubs and delays, while frustrating, are an integral part of ensuring safety and maximizing the chances of success on the next attempt. Every postponed launch is a decision made in favor of prudence, a choice to gather more data and triple-check every system before committing to flight. The wait for Starship's next fiery ascent continues, but the vision for the future has never been clearer. The astonishing, record-setting performance of the Falcon 9 fleet this week is not a separate story. It is the prologue. It is proof that SpaceX possesses the operational excellence and relentless drive to turn ambitious goals into routine reality. While Starship's moment was delayed, the incredible pace of its predecessor shows that when the time is right, SpaceX will be more than ready to fly. The future is simply on a brief hold.